Go.
Okay, so today is, we're making up the pages that we're missing because it's a snow day. And those will be pages 49, 50, 51, 52, and 53 in the notes. So, Elise, thank you for being my student today. Okay, so we're going to start right here, and we're starting at this equation. And what we're looking at is the control of blood pressure and blood flow through the systemic circuit. So this is an important equation right here. Super important. It got stars around it, it got all kinds of things around it because they really need to know this equation. And this is looking at mean arterial pressure. So this is basically when you're measuring somebody's blood pressure, you're looking at what is going to determine somebody's blood pressure. And these are the two variables that are going to determine it. Cardiac output is over here. And do you remember when you came to class we talked about cardiac output? It equals stroke volume times heart rate, and then you were in the video and you talked about what stroke volume is determined by. Do you remember that?
Yes.
And then so cardiac output is going to determine your blood pressure, so how well the heart is functioning. But then this is also going to determine blood pressure, and this is total peripheral resistance. So this is how much resistance there is in all of your blood vessels. And really the most important ones are the arterioles, because they're the ones that can change their diameter or their radius and offer more or less resistance. So we're going to start off with short-term mechanisms. So short-term mechanisms that are going to be involved in determining your blood pressure. And short-term mechanisms are kind of like if you stand up suddenly, your body can basically understands that you're standing up. It realizes that your pressure has dropped for that moment that you stood up, and it can correct for that. So that's a short-term mechanism. It corrects for really sudden increases or decreases in blood pressure. And then we're going to look at some mechanisms later on that talk about what if you actually, it's more than just a short-term increase or decrease in blood pressure. What does the body do to correct for that? Okay, so we're going to start with the short-term ones. So we're going to start with something called the cardiovascular center. So do you know what cardio refers to? Your
Heart.
Good. And vascular refers to your vessels, your blood vessels. And so the cardiovascular center is going to control the heart, and it's going to control the blood vessels. Okay, so we have basically from the cardiovascular center, we have nerve fibers that are called vasomotor nerve fibers. So vasomotor, vaso means vessel, and motor refers to it's going to the muscle of the blood vessel. So when you have like a little arterial, okay, so if we draw a picture of an arterial, in the wall of the arterial, you have muscle. And so you're going to have little motor neurons that are going to control whether or not that muscle is contracting or relaxing. And that's going to then control the size of the lumen of the vessel. Okay, so those are the neurons that we're looking at. So they're motor neurons. They're efferent, and that's because they're leaving the central nervous system. So that's what we're looking at. Vasomotor nerve fibers, efferent fibers that regulate the blood vessel radii, so the radius of the blood vessel, and they do that by causing the smooth muscle of the arterial specifically to contract or to relax. Okay? And what are these vasomotor nerve fibers? They're part of the sympathetic autonomic nervous system. So sympathetic autonomic nervous system is the fight or flight response of the autonomic nervous system. Like if you get really scared, then you want to do what? If somebody scares you, you either want to do what or what?
Scream.
Okay, so scream, so that and scream and either run, that would be flight, or fight him. Okay, and either way, whether you're getting ready to run or you're getting ready to fight him, your sympathetic nervous system is the one that is going to be activated. That's the division that's going to be activated. And that's going to cause your total peripheral resistance to increase. Sympathetic nervous system is going to cause your cardiac output to increase, and those two are going to cause your blood pressure to go up. So if you're scared, your blood pressure goes up, okay, because your sympathetic nervous system is activated. So this is showing what happens here. Down here, this is part of the sympathetic. It's a sympathetic motor neuron. It's going to release a neurotransmitter, and that neurotransmitter is noradrenaline. It's kind of like adrenaline, and the other name for that is norepinephrine or epinephrine. Okay, so epinephrine is basically the neurotransmitter that's going to be released. So that's like the fight or flight response is kind of when your adrenaline is being released, like you feel the adrenaline rush. Okay, so have you ever heard that, having an adrenaline rush? Okay, and then epi, do you remember when we had to carry that EpiPen for Christine?
No, it was Catherine.
Really?
Yeah.
It wasn't Christine?
It was Catherine Zimmerman.
Oh, okay. Okay, do you remember that?
Yeah.
And why do we have to do that? Because she was at risk for what?
Allergic to peanuts.
She was allergic to peanuts, so we had to carry that. So we'll talk about that later, okay? Why that is, but it has to do with going back to the... Okay, so we're still on this. So what happens is if we have fewer vasoconstrictor, vasomotor fiber activity, there's going to be less noradrenaline being released. If there's less noradrenaline released, then there's going to be vessel relaxation, increased vessel radius size, decreased resistance, and your blood pressure is going to go down. On the other hand, this is what we saw before, if we have more sympathetic activity to a vessel, more noradrenaline being released, the vessels are going to constrict, and then they're going to get more narrow. Their vessel radius is going to decrease. That's going to increase their resistance to blood flow, and blood pressure is going to go up. Okay, so that's kind of, we're looking at either turning on the sympathetic nervous system or turning off the sympathetic nervous system. So something has to control all of this, and that brings us to the cardiovascular center. So we're going to look at a picture. You ready to look at a picture?
Sorry.
Okay. So this is the picture that we're looking at. So do you know what this is a picture of right here? Do you know what that is?
A brain.
A brain. And then we're looking specifically here. This is called the brain stem. And then this is the medulla of the brain stem. And that's where the cardiovascular center is. And do you see we have blue arrows? So what do you think that means? They're going to do what? They're going in which direction? Towards or away from the towards the cardiovascular center. So these blue arrows are kind of telling the cardiovascular center what's going on in the body. Okay, because the cardiovascular center wants to know. It's like, what is going on? Okay? And then in response to what is going on in the body, then the cardiovascular center is going to do what? What direction is this arrow? Away. So it's going to go influence. And what is it going to influence? Output to effectors, and the effectors are your
Heart.
And your
Body, blood vessels.
Yeah. Okay, so that goes back to this equation here. Remember, cardiac output was your heart. Total peripheral resistance referred to your blood vessels. So that's what the cardiovascular center is going to send signals to. Okay? You ready?
For what?
For this. Okay. So we're going to kind of look at these two together. So we already looked at the cardiovascular center. It's in the brain stem. And it regulates impulses to the heart. And by regulating impulses to the heart, it's regulating cardiac output. And then going back to the equation up here, by regulating cardiac output, you're regulating somebody's blood pressure. Okay? It also is going to regulate impulses to the vasomotor center, so to the blood vessels. And that regulates blood vessel resistance. Okay, whether they constrict or they dilate. And that, again, going back to this equation, by regulating blood vessel resistance, you're going to regulate blood pressure. So again, go back to that equation. Always go back to this equation. So this is always active. You're always going to have some degree of vasoconstriction. So that means your arterioles, if we go back to that little picture here, your arterioles are always to some degree vasoconstricted, okay? So it's not like they're ever totally vasodilated. Because if they were, what is happening to the radius here if you vasodilate? Is it getting bigger or smaller when you vasodilate?
Bigger.
Bigger. So the radius is getting bigger. And when the radius is getting bigger, guess what that's doing to the resistance? It's making it lower. Okay, so if that's causing the resistance to go lower. So if it goes all the way down to 0, okay, if you weren't vasodilating and your resistance would become 0 resistance, what would happen to your pressure? If this was 0, your blood pressure would become what? 0 times anything is what?
0.
0. And do you think that sounds good?
No.
To have no blood pressure?
No.
No, that's like really, really bad. Okay, so we always have some degree of vasomotor tone because we always want to have a blood pressure. Okay, so these are always going to be active in causing some vasoconstriction, but it changes how much vasoconstriction. Okay, so this bit here that we're looking at here then is, remember we said there are certain things that are arrows going into the cardiovascular center, and these are going to be from certain areas. So that's what this is saying. What is influencing the cardiovascular center? So higher brain centers are going to influence the cardiovascular center. So that means like you can think about something, and if it makes you nervous or excited or whatever, that is going to influence the cardiovascular center. So just thinking about something, higher brain centers, and that could cause your heart rate to go up and your blood pressure to go up. Then we have another thing that's going to influence the cardiovascular center are baroreceptors. Have you ever heard of a barometer?
Yeah, it doesn't measure the air pressure.
It measures the air pressure, right. So this is baro means pressure, and in this case it's not measuring the air pressure, but it's measuring your blood pressure. So you have these baroreceptors, and they also go to the cardiovascular center and they say, hey, this is what's happening with the blood pressure. It's either high or low or just right, okay? And then the cardiovascular center will respond to that. Then we have chemoreceptors. Chemo means chemicals. So chemoreceptors are monitoring the levels of hydrogen, carbon dioxide, and oxygen in the blood. And they also are going to tell the cardiovascular center what's going up. So what do you think it means, like if there's too little oxygen in your blood, what does that tell you if there's too little oxygen? Do we need to get more oxygen? Yeah, and the tissues may not be getting enough of it. So we better tell the cardiovascular center so that they can try to get more blood to the tissues. Does that make sense?
Yeah.
And carbon dioxide also, if you have too much carbon dioxide, you're going to have the cardiovascular center is going to increase impulses to the vasoconstrictors, and that's also going to then, again, we know from the equation, cause blood pressure to go up. And then this is kind of cool. The last of the influences to the cardiovascular center are proprioceptors. And proprioceptors, they monitor basically what's happening in your joints. They tell you what your body is doing, kind of what your joints are doing in space without you having to look at them. Isn't that weird? So like if you close your eyes, do you know where your arms are?
Yeah.
And your legs and everything. And that's because of these proprioceptors. And they're also going to go to the cardiovascular center, and they're going to influence it. So if you start running, the proprioceptors are going to say, hey, cardiovascular center, we're running now, we're starting to run. And guess what, cardiovascular center, because we're starting to run, our muscles are going to need to have a higher blood pressure. They're going to need to get more blood. Okay, so the proprioceptors account for why even when you start exercising, your heart rate goes up, okay? There goes Mocha. Okay, so do you get that, Eric?
Yeah.
At least? Eric's videotaping. Okay, so the next thing is neural regulation of blood pressure. So neural regulation of blood pressure by way of the ones that we know already, the baroreceptors and the chemoreceptors. So the baroreceptors are pressure receptors, you said that already, and they're located in your aortic arch, your carotid sinus, and other large arteries of the neck and the thorax. So do you know where your carotid arteries are in your neck? So, okay, let's stop.